Today we will discuss the effect of centrifugal force on acceleration due to gravity, that is the value of g. So what is the effect of centrifugal force on the value of g? So this is our previous background about this article. That is, this is a diagram and body is lying at this point. That any body of mass m is placed at this point having angle of latitude is lambda, and these are the three axes: x axis, y axis, z axis, and this vector is r vector, and this force is centrifugal force. So this force we have studied in the previous lecture. Now we will study the effect of this force on the value of g. So this is our simple vector diagram. This particle is assumed at here, and this force, centrifugal force, is acting on this particle on this side, and the weight, that is mg weight, which is also called mg weight, it is acting along this side because weight is along the center of earth. So here mg, and along this side is centrifugal force, this one, the two forces. So we are applying the triangle law or parallelogram law of vector addition. There are two vectors acting on a single particle, then the resultant of these two vectors is this. So this one is the resultant. It is resultant force. So net force is acting on this particle along this side. Okay, so it is resultant of both these forces. So we will discuss this resultant with respect to these two forces. So the equation, or mathematically, this equation of force may be written as the net force is F dash, resultant force is F dash, and it is the sum of F, that is weight, and plus centrifugal force, centrifugal. So this is the equation of force. The sum of two vectors is equal to the resultant vector. Okay. Yes. Now we will study or solve this equation of force by using its components. So what is this? It is nothing. It is taken as mg dash, because force is ma or mg. It is mg dash. G dash means resultant. Means in this figure it is the resultant. It will be the mg dash. It is mg, and this one is Coriolis force. So F is m into g vector. Okay, and this centrifugal force. So we have studied the centrifugal force in the previous lecture, that the value of this force is equal to m omega square r cos lambda, m omega square r cos lambda into j. So this is the value of centrifugal force which we have studied in the previous case. So what is the value of this g vector in component form? From diagram, this g vector is equal to this one g. It is magnitude of this g is g, and the direction is minus r cap. Is it clear? Because this vector is r in upward direction. In downward direction, it is minus r. So we are taking its direction, that is its cap, unit vector, and the value of gravity is g. So vector may be written as its magnitude and its direction. The value is g, and direction is minus r cap. Okay, and this one is minus g into r cap. So what is r cap? R cap, this r vector has two components, r cos lambda and r sin lambda, and r cap is r vector upon r magnitude. So r cos lambda j, because it is along y axis, and r sin lambda into k, it is along z axis, over r. So this r will cancel with r, taking common r from numerator, and it will cancel with the denominator r. So r cap is equal to cos lambda j and sine lambda k. Now putting this value r cap here, and we will get g vector. So g vector is minus g into this one cos lambda j plus sine lambda into k. So put this value in this equation. Just let it is equation number 1. So putting this value in equation number 1. Now on the right hand it is completely equation in component form. G vector is this. So I have split all vectors into components. G vector is minus, so we can take this minus as common. It is minus into g cos lambda j plus sine lambda k. Sorry. Okay. And plus this value is m omega square r cos lambda. Okay. Now this m can be taken as common from right hand side m, and it m with is cancelled with m on left hand side. So ultimately it will become g dash vector is equal to, this is the final, it is j. Now we can combine the j components as well as k components. Here it is minus g cos lambda minus g cos lambda and plus omega square r cos lambda into j cap plus, sorry, minus into this minus g into sine lambda and k cap. So this g vector has two components. One component is along j side, that is y axis, other is along z axis, that is along k side. Now the resultant, you will find the magnitude of this vector. So what is the magnitude? Magnitude is the square of both components and under root. That is, it is minus, I think cos lambda is common. So cos lambda is common, and it is minus g and plus omega square r and whole square, this one whole square, and this one is minus g sine lambda whole square. Okay, is it clear? So it is nothing, it is the coefficient of j, this one, the square of coefficient of j plus square of coefficient of k. Okay, so we can do the square of these two and we will solve it. So finally you will get, you can solve it yourself, and you will find that this g dash is equal to, this g dash is equal to square root of or under root of g square plus omega 4 r square into cos square lambda minus 2 omega square r g 2 omega square r g into cos square lambda. You can solve this article, that is square of this, it is cos square into this one, a square plus b square plus 2ab, and this one, you can solve it. You will find this answer. And finally here it is omega power 4. So this term can be neglected. Why? Because omega is very small. Omega is very small. Value of omega. Omega means angular velocity of Earth. This value is very small. When we take the fourth power of this small value, it will tend to 0. So we can neglect this term because this term becomes 0. This will become g dash is equal to under root of g square minus, g square minus 2 omega square r g into cos square lambda. Okay. Now you will take common g square from the side to make the first term as 1. So taking g square as common, and it will become g on outside the square root to 1 minus 2 omega square r in g into cos square lambda over g square. So g square common, dividing both term by g square. So g square is cancelled g. And now we will consider this g into 1 minus 2 omega square r cos square lambda over g power raised to power 1 by 2. Cos square root is 1 by 2. And we will apply the binomial theorem, special case of binomial theorem, 1 minus x raised to power n, that is 1 minus nx. And higher terms can be neglected, because in high terms this omega square become omega power 4, omega power 6, omega power 8. In this way, as the power of omega increased, the value of omega, that power is reduced to 0. So this g dash becomes g into 1 minus nx, means half is here, 2 is cancelled. So it is omega square r into cos square lambda over g. To omega square r cos square lambda upon g. So we will take again, multiply with g minus omega square r into cos square lambda, and g is cancelled with g. So g dash is this. I think you have read this equation in 10+1 class also. So this is proved by using vector addition formula. In +1 class we have used simple method to solve this equation. So it is same equation. So we will discuss its special cases. Special cases. First, at pole means when this object is lying at this point, pole. So we know that at pole this angle become 90. At pole lambda is equal to 90 degree. When lambda is 90 degree, then we will put here, it will become g minus omega square r into cos square 90. Cos 90 square, cos 90 means 0. So it will become 0, 0 square 0. So ultimately g dash become g. So this is the equation for acceleration due to gravity at pole. Pole, g dash means it is pole. At pole the gravity is same as that of actual value 9.8. And second case, we will put the second case at equator. At equator this lambda become 0 degree. Equator means when this object is lying at this point, equator, this because this line is equatorial line and this is polar line. So when object is lying at this point, then this lambda become 0. So when we put lambda 0 here, we will get g dash is equal to g minus omega square r into cos 0, cos 0 1, that is omega square r. So this is equation for gravity, acceleration due to gravity at equator. So this may be written as GE, equator, or it is g minus omega square r, and this is written as GP, that is g pole, is equal to g. So these are two results, first and second. So from these results it is clear that the gravity, acceleration due to gravity, is same as actual value 9.8 at pole, but its value is less because g minus something, its value is less than g. So GP is greater than GE because GE is less than G. Okay, gravity at equator is less than gravity at pole. Gravity at pole is more than gravity at equator. So when a body is placed at here, at this point, then its gravity is more. When it is lying at this point, the acceleration due to gravity is less. So the weight of the body on pole is more than that of the weight of the body at equator. So these are the results which we have discussed in the previous class also. If we change the fractional change, we see the fractional change in the value of g. So what is fractional change? It is delta g. What is delta g? It is gp minus ge. Gravity at pole is more and gravity at equator is less. Therefore, difference in gravity at pole and equator is called change in gravity. It will become Gp means G minus Ge means G minus minus plus omega square r. So Gg cancel with and delta G become omega square r, and fraction means it is divided with G. Fraction means ratio. The change in gravity to the actual gravity. It will become omega square r upon G. So this is fraction change in gravity. So this is the actual practical effect of centrifugal force on the value of acceleration due to gravity. In our next lecture, we will study the effect of Coriolis force on the displacement or position of the body. Thank you very much.